In today's lab, you guys are going to be suffering through an empathy experiment. We call it the Rutherford Lab because Ernest Rutherford in 1911 discovered where almost all of the mass of an atom is, in the nucleus. This model improved on J.J. Thomson's plum pudding model, or you could call it the chocolate chip cookie model. Thomson knew that there was positive stuff, you'd call those the plums, and negative stuff, you'd call the pudding, or these could be the chocolate chips and this could be the cookie. And so Rutherford set up this exquisitely elegant experiment where he used a radioactive source that was an unstable nucleus. As it fell apart, it gave off alpha particles. Now, alpha particles are really just helium nuclei without electrons. So imagine you've made a helium cannon. You're shooting these helium atoms at gold foil. And in the Rutherford model, those helium atoms actually bounced back or were deflected. If the Thomson model was true, there wouldn't have been enough mass anywhere in the atom. There would not have been enough concentrated mass for this to happen. And the nuclei of helium, those alpha particles, would have passed right through. Okay, so today's lab is an empathy experiment because Rutherford couldn't see the nucleus, but he had to find out if something was in there. He did find out that the nucleus and all of the mass was in this excruciatingly tiny place right in the middle of the atom. But he couldn't look at it. Today, you guys have these boards and no peeking. Underneath these boards are irregular shapes. There is one irregular shape under each board. And so we want you and your partners to grab a piece of paper, place it on the board, use a couple of pieces of tape to hold it in place, find the arrow of the board, that's your orientation, find the number of the board, that'll match the key. You want to know that because tomorrow we will show you the shape that was underneath your board, but we won't show you the board. We'll show you a picture of that shape, and you can compare it to the shape that you drew. That's where we come to the most difficult part. How are you going to determine the shape under the board? Well, in this analogy, you're going to use marbles as the alpha particles. So pick out a marble, bring it back to your board, and then you can roll your marble under the board. All right. Looks like my marble went in like this and then deflected out that way. You're using your marble as a sensor to detect the shape of the thing underneath your board. And in this case, since our angle of incidence should equal our angle of reflection, we may have a surface on an angle like that we've hit. Keep going all the way around your board until you feel confident about your irregular shape. Finally, try not to lose your alpha particle. We've placed rulers all around the classroom, and you can set those up as little barricades to keep your alpha particle from rolling away. It might catch your, it didn't work very well. Yeah, something like that. It'll stop it, and then you can proceed around your board to try to figure out what that shape is. When you're all done, take your alpha particle, put it back in the alpha particles bin, and take your paper and take it off of this board and hand it into your teacher. Make sure that all of your group members' names are on the paper. Good luck, everybody.